So in this video, we're going to figure out how to solve for the effective IRR of a project. Now, this is a final exam question because students typically don't really know how to mix what they learn in the time value of money chapter with the capital budgeting chapter. But after this video, you'll be a pro. And we're going to be looking at two different instances, two different questions at which you will need to solve for the effective IRR. Now, before you make the small adjustment to find the annual internal rate of return, it's typically business as usual. You just got to solve for the IRR, but then you got to bring it back to just span 1 year. This video will really show you how to do this, and you'll be now equipped to master your intro to finance class or master your MBA, program at which you're looking at a finance course, or even your level 1 CFA if they look at this stuff. So let's jump into it. We're going to look at two questions, and you're going to become a pro after this. By the way, I like to go on spiels or like monologues, talk a lot, so don't hesitate to skip through the video. In an ideal world, there are timestamps. So let's go. So Kurahara Sensei is considering a project that diversify his family's portfolio. The project is going to cost $75K, and it'll generate perpetual cash flows. Okay, perpetual cash flows of $6,750 every 3 years forever. Okay, so this is already getting kind of strange. Okay. And with that, we want to find the internal rate of return of the project. But in this case, what you really want to find is the annual IRR of the project. Like for 1 year, what would be your ideal, indifferent return? So what we're going to do is, once again, the IRR is this given point, is a specific objective point at which the NPV of a project will be equal to 0. And the NPV is simple. It's the present value of the cash flows less the initial investment. So we just want to make that equal to 0, right? We want those two to essentially cancel themselves out. And that given K, that gives you that point. Well, that's going to be your IRR. But in this case, our given K will be interesting because it's a specific one that's going to span 3 years, but we want the K that spans 1 year. You'll see what I mean in just a second. So our CF0 is equal to $75,000. Okay, and our perpetual cash flows will be payment 1 to 3 is equal to $6,750. Okay. And remember, this is happening every 3 years. Alrighty, every 3 years. Some important stuff. Alrighty. So what is the internal rate of return of this project? Now, for this, I always like to visualize these problems to really make sense of what the heck is going on. And we're going to do that. It's something that we did a lot within the time value of money chapter. And it's something that we're going to replicate here because it's really going to help you visualize what the hell is going on. So we're going to have t equals 0, t equals 1, t equals 2, t equals 3, t equals 4, 5, 6, 7. I guess we'll add another one just such that we get all the way to t equals 9. So we have a bunch of different points within our timeline, and every single one of these points are going to represent 1 year. Okay, so what we're going to do is we're going to try to plot the information that was provided in the question on our timeline. It's an amazing tool. Even PhDs, even myself, who I don't take the class anymore, I graduated, I use this to try to solve these questions before I give them out. It's an amazing tool to use. Trust me, use your timeline. It's helpful. So we're going to have minus, right? That's our cash outflow today, right? Minus $75,000. And then we're going to use green to highlight our cash inflows. So we know that this will happen every 3 years. Okay. So in this case, what I'll do is just for fun, is we're going to say that our first cash flow, so we'll put it here. Or actually, no, yeah, whatever, it's not that important. What I wanted to really showcase is that we have 1 year passing, 2 years passing, 3 years passing. We have another payment here. 1 year passing, 2 year passing, 3 year passing. We're going to have another payment here. So notice how our payments are occurring every 3 years. This is just a visual tool. We're not going as deep as with chapter 5, where they need to tell you at what year that payment is happening. I'm just really trying to showcase, well, okay, we have payments essentially occurring every 3 years. Okay, so every 3 years we're going to have a payment. And in this case, we notice that we have essentially a perpetuity, right? We know that every 3 years a payment will occur. So if you remember what we used to do in chapter 5, you would remember that we would group these payments as being one large payment, right? Every 3 years, you're going to have one large payment. And I think I had a lisp on that one. I was like, right. But anywho, we're going to span these as being one large payment. Okay, look at that. Starting to make sense a little bit. Now, we know that this one large payment that spans 3 years, well, we could set it equal to our initial investment to solve for that given K. So if we were to plug that in within our formula, right, if we want to solve for IRR, we can use a different color here, we would have 0 is equal to the present value of our future cash flows plus our initial investment. In this case, we're going to have payment over K. Remember that payment is essentially spanning 3 years. That over K. And of course, we're solving for K. And our initial investment here is once again CF0. So here we're going to have 0 is equal to 6,750 divided by K. So again, we're solving for K. Hope that's clear. Our initial investment is $75,000. Now, you could plug it in within your calculator super quickly. It's very simple to do. So what I'll do now is I'm going to do we're going to solve for K. In this case, our K is 9%. So I'll write it here. Actually, I'll just bring this up and I'll write it. This is just a simple, type of high school math. So I won't take too much time in covering what we need to do. K will be equal to 9%. All right. So notice how we do this. 6,750 divided by 0.09, you will get 75,000. So now you have your K, which is 9%. However, what you need to understand here, okay, is that that K represents 3 years of interest. Okay, it represents 3 years of interest. It actually represents T1 all the way to T3 and so on and so forth, right? It represents that kind of like that loop happening every 3 years. So that K isn't your annual effective. It's not your like annual or your effective annual rate. It's not your actual IRR for one given year. So what you're going to need to do is you're going to need to like look a little bit deeper. And remember that formula that we had to find the effective periodic rate, right, from an annual rate. Okay, so I'll show you how we do that in just a sec. So how we would go about this is fairly easy. Okay, remember this formula where we had the effective? And I'll zoom in a little bit just to make it, oh, sorry about that. I'll zoom in a little bit such that it's a little bit easier to see. But remember this, in our time value of money chapter, and there are some videos on this, we knew that the effective periodic rate was simply equal to 1 plus the quoted rate over 1, to the exponent of 1 over m. This would be minus 1. However, in this case, we have the effective periodic rate. We have m, but we don't have our quoted rate. Our quoted rate would be our annual rate in this case. So what you could do is literally, once again, solve for the missing variable. In this case, we know that our effective periodic rate is equal to 0.09. We know that that is equal to 1 plus x, which is our quoted rate, over, in this case, 1 over 3 minus 1, right? That's our power. So you could simplify this further to being 0.09 is equal to 1 plus x to the power of 3 minus 1. And then you would find that if you were to solve for x, I could do the mathematical proof, but I'm a lazy person. And I'm just going to plug it in straight into my symbol lab. But it's simple. You just bring 1 to the other side. So you have 1.09 is equal to 1 plus x to the power of 3. Then you would take the, not the square root, but you would take like the cube root, I guess, and that would give you your answer here. This one. Yeah, that is fair. Cool. So our x would be 2.914%. And that would be our annual IRR. Okay, that would be our annual IRR. It's as simple as that. 2.914%. And you could actually do a quick proof and do 1.0214 to the power of 3, and you would get essentially 9%. So this would be how you find your effective annual rate. And it's as simple as that. Okay. So let me just take a step back before we jump into another example of this, but I really want you to understand why we kind of had to find our effective annual internal rate of return. In this case, we knew that our payment was occurring every third year. It's not happening every year. For that reason, we grouped our payment as one that spans 3 periods, 3 years. Okay. So payment spans 3 years over K. And in this case, our K will represent the amount of interest you would actually have after 3 years. It doesn't show how much interest you would generate after 1 year. So we need to use our effective periodic rate formula. But now we're not solving for the effective periodic rate because we have it, right? We have the rate that spans 3 years. We want to find the rate that spans 1 year. So instead of solving for EPR, we're solving for QR. And QR in this case is 2.914%. Okay? Don't worry. If that wasn't so clear just yet, if you don't feel like you mastered the topic now, we can take a step back. And we're going to do another question that asks us to solve for the effective annual internal rate of return. Okay, so the next one on page 18 is extremely similar. Okay, so Bloomberg's pension department, so apparently they have a pension fund or whatever, wants to invest in a risky project that's going to cost $28,500. Okay, now we know what to do. So we could kind of run through this. We know that this will be our CF0. CF0 is equal to 28,500. We know that this project is going to yield perpetual cash flows of $8,500 every 5 years. Okay, every 5 years. Now, what is the internal rate of return? That's going to be our mission. That's what we're solving for. What is the internal rate of return of this project? All right. So in this case, you know that payment 125 is equal to $8,500. Okay. I'm going to draw the timeline super quick, but I'm not going to be super exhaustive about it. What we're going to do is we're going to make it quick and easy. So we have here t is equal to 0. I'm going to have t is equal to 3. T is equal to 5. T is equal to 8. Then t is equal to 10. It's not a formal timeline. It's just to really showcase what we're dealing with once again. So here we have 28,500. At 3, we're going to have nothing. But at 5, we will. At 5, we're going to have 8,500. And at 10, we're going to have 8,500. And this is going to happen forever. Okay. So we know that our cash flows will essentially span 5 years. Okay. So we know our cash flows, they span 5 years. Okay. And then we can do that once again, I guess, for the second bucket here. So you know that your cash flows, they span 5 years, and this is going to happen forever. Okay. And because we know that our IRR is a specific point, right? It's a point at which your NPV is equal to 0. We're going to solve for that given K. All right. So it's simple. In this case, we know that 0 will be equal to the present value of your CFs, your future CFs, minus your initial investment of CF0. You know that 0 is equal to essentially payment over K. You know that payment will last years. You know that your CF0 remains such that you're going to have 0 is equal to 8,500 over that given K that we don't know just yet. And like that, you're going to have your CF0 that's equal to 28,500. And it becomes a very simple game of solving for X. Honestly, all that you have to do is you have to do 8,500 divided by 28,500. And you're going to get 29.83% type of thing. 29.83%. Let me just double down to make sure that's correct, but you're going to get something along those lines. Yeah, we'll go with that, 29.83%. But once again, you remember that this is not your final answer. It cannot be your final answer because this will span 5 years. This is not your effective annual rate, okay? So what you can do in order to find your effective annual rate is pretty straightforward. All you got to do is use your effective periodic rate formula. So EPR, right, is equal to 1 plus the quoted rate to the power of 1 over m minus 1. In this case, we know that our rate is 29.83%. We know that that is equal to 1 plus x, which is our quoted rate, right? Our annual rate, to the power of 1 over 5 minus 1. In other words, it will be equal to 29.83% equal to 1 plus x to the power of 5 minus 1, such that x will be equal to that should be correct. It'll be equal to, let me find it for y'all. Where's my answer? Should be 0.05359. So we're going to say 5.359%. This is going to be your answer. This will be your annual IRR. This is going to be the actual internal rate of return that you're making on a year-to-year basis, rather than on a 5-year basis. Okay? It's really as easy as that. And I'm going to take a quick step back to make sure that this is the correct amount, but I am pretty confident here. Yeah, you know, there's a slight nuance here, I believe 0.559. Yeah, that's okay with me. We could go with that. And that would be our answer. So really the real framework to have here is that when they give you cash flows that are not occurring on a year-to-year basis, they're occurring, call it every 2 years, every 3 years, every 5 years. Well, you need to really get your annual rate. You want to find the internal rate of return on a year-to-year basis. You don't want the internal rate of return on a 5-year basis. What does that really tell you? How do you compare that to your discount rate? You can't really do so. So in this case, we need to bring back our internal rate of return to an annual basis. And we use the effective periodic rate formula to do so. But in this case, we're not solving for the effective periodic rate. We're solving for the actual annual rate, okay? And that's why we got to reverse engineer our way to finding that missing variable, to find that x. And this is something that you actually may see on your exam. It's not a classic solve for IRR. Students may fall for that mistake. This is a solving for IRR question that can be a multiple choice on your final exam, in which you're going to have to really just think deeper for a second. Visualize what we have here, especially if you've done the questions that I have on my YouTube channel and on my website on TVM. You would know that we can't simply just take that 29% as being your annual rate. It wouldn't make sense, right? That's how much you're making over, in this case, 5 years. The previous question was 9% over 3 years. That's not what you're making on a year-to-year basis. It's important to have that in mind. So with that information out there, hopefully this video helped you out. Hopefully this puts you in the right track. And hopefully this will help you, like I guess, empower you to solve a exam question that you may see like this on an exam. So listen, if you want more information, more resources, there's a bunch of resources on my YouTube channel, in which you have step-by-step videos that are going through exam-like questions that are explaining topics that you will need to master for your intro to finance class. For an undergrad, either a finance class under your MBA or a level 1 CFA, at least an introduction to that. If you want more PDFs, more resources, more static questions, or even interactive problems, you can go on my website, eastmanhelps.com, in which you're going to find everything that you need there. Okay. Hopefully this helped you out. I'll see you on the next one.